In this short video, I'm going to walk you through the proof of why the derivative of the ln of x is 1 over x. Okay, so if you think about it, we want to find the derivative of the original function, which is y equals the natural log of x. Okay, but I have no idea how to take derivatives of natural log of x. That's why I'm doing this problem. However, we know that ln and e's are have a relationship. And so what that relationship is that if you have a equals ln b, this is the same thing as e to the a equals b. Okay, so that's a fact about natural logs and e's when they are first defined in algebra. Okay, so if I come and write that relationship over here, that's saying that e to the y equals x. Okay, so I do know how to take derivatives of e. So here's what we're going to do. We're going to take the derivative with respect to x of e to the y equals x. So the derivative of e to anything is itself times the derivative of the exponent. So because the y is not an x, that's going to be a dy dx. Okay. What's the derivative of x? 1. Okay, so we're basically using implicit differentiation. So what I want to do is I want to solve for this dy dx. Okay, so when I solve for this dy dx, I get 1 over e to the y. Well, that's fantastic, except the original was defined as a function of x. So if your original function is defined all in x's, my answer should be all defined in x's. So here's what we're going to do. We know that e to the y is the same thing as x. So that means that this is the same thing as 1 over x. So that's how we got the fact that if y equals the natural log of x, its derivative is 1 over x. You don't have to be able to do this proof. It's pretty easy though. And this idea of using implicit differentiation is actually how we also get derivatives in the next section, 3.10. So we're going to look at inverse sine, inverse cosine, and inverse tangent. And so if you can understand this proof, you'll understand those proofs as well. All right, good luck.